All right. We're going to move on to algebraic expressions. Now, an algebraic expression has a variable in it. Or multiple variables, but it could have any number of variables, really. A variable is a letter used to represent one or more numbers. Okay, so a variable could be, for instance, x. We could have x as a variable. Well, that's all well and good. But what if we do stuff to x? If we had x plus 3, well now we have an algebraic expression. X plus 3. We have a variable, we have numbers, and we have operations. In this case, we have the variable x, we have the number 3, and we have the operation of plus. Now, when we look at variables, a lot of times we will have a number in front of the variable. This number in front of the variable is multiplying that variable. So 3x here is 3 times x. This 3 is a coefficient. So a number multiplying the variable is in front of the variable, and it is a coefficient. Usually we will not put these numbers behind the variable because that can get confusing with a power, and we don't want to deal with that. There's a couple of other things I wanted to just briefly mention here. The first being that we have two different terms. Now, a term is simply one of the things that's being added or subtracted or whatever in an expression. So here I have the term 3x and I have the term 3. Since 3x has a variable in it, it's a variable term. Since 3 does not have a variable, it's just a number, it's a constant term. So we need to sort of keep those two separate. If I say the constant term, we need to know that I'm talking about the term that doesn't have a variable. All right. Now, when we're dealing with algebraic expressions, one of the main things we're going to have to do is evaluate them. Evaluating something as a direction basically means to substitute in a number for the variable if that's required, and then finding the single number answer. Evaluate problems always give you a single number answer. To do this, it's actually fairly straightforward. Since x equals -3, all I want to do is rewrite this expression. Anywhere I see x, I'm going to replace it with -3. I'm not going to change anything else until I start to use the order of operations to simplify and evaluate the expression. So, let's start with our substitution. All right, we want to substitute. We have -4. I'm substituting -3 in for x. Nothing else has changed. It's still -4 times -3 squared minus 6 times -3. Again, nothing else has changed. It's still minus 6 times, but now instead of x I have -3 plus 11. So I've substituted in. That is the first step in an evaluate problem. The next step will be to begin the order of operations, because now this is not an algebraic expression. It's a numerical expression because it's all numbers. Here, I want to start with PEMDAS. Now, these -3's are in parentheses, but since there's no operations being done inside the parentheses, I'm not worried about getting rid of them. I only want to worry about parentheses if there's some sort of operation being done inside them. So I'm going to skip the parentheses part. What I am going to do is deal with the exponents. And I have some exponents. I have negative 3 squared, as a matter of fact. Nothing else is going to change. It's still going to be negative 4. But now I've got negative 3 squared. Now, a quick word about this. Since this is negative 3 squared, what I'm literally saying is negative 3 times negative 3. Negative 3 times negative 3. Well, a negative times a negative is a positive, so my answer is going to have to be positive. And 3 times 3 is 9. So negative 3 squared is positive 9. So I'm going to replace negative 3 squared with positive 9. And that is all I'm going to do in this step, because I was just concerned with the exponents. Now I'm going to move on. The thing I want to deal with next, since I don't have any division, I'm just looking at my multiplication. So I'm going to multiply. And I do have some multiplying that can be done. I have negative 4 times 9. I have negative 6 times negative 3. This minus sign does move with the 6. Negative 6 times negative 3 is different than 6 times negative 3. So I've multiplied negative 4 times 9 and negative 6 times negative 3. And I've got negative 36 plus 18 plus 11. That's all of my multiplication. My last step then is simply to add. So I'm going to add for my last step. I have negative 36 plus 18 plus 11, and the calculator tells me that that is negative 7. So that is my answer, negative 7. I started with an algebraic expression, and I ended with a single number answer. That is the way it will usually go with an evaluate type of question. I want you to give this problem a shot. I want you to pause the video, try to answer this question. In just a moment, I'll put up the answers so that you can look at it, and then you can see how you did. If you had any problems with it, or if you didn't get the answer that I got, feel free to hold on to it and ask me about it in class or in tutorials. All right, here is the answer. The final answer was 5. As you could see, I had to substitute and multiply to get and subtract to get down to the 5 answer. I didn't have to do any parentheses or exponents. I didn't have to do any division or addition because they weren't there. All right. Now we're dealing with expressions that have variables in them because they're algebraic expressions, and what we're going to have to be able to do is simplify them. Now, an expression is simplified if all like terms are combined and there are no parentheses. So, our example here, we have parentheses, and we have terms that are going to be like, but we have to get rid of the parentheses first. So that's going to be my first step, is to get rid of the parentheses. Now, to get rid of these, I have to use the distribution property. All right. When I distribute, that means that I multiply the number outside the parentheses by the numbers inside the parentheses. So I have 2 times y is 2y. 2 times 5 is 10. Here I have negative 3 because the negative sign has to travel with the 3. Negative 3 times y is negative 3y. Negative 3 times negative 9 is positive 27. Now, I might want to group these together. That's usually a good way of going about this. I have 2y and negative 3y. I have 10, and 27. Now notice that I've put circles around the y's and squares around the constant terms. Now I do that just to keep it straight so that it's easier to do the grouping. So I have 2y minus 3y. I can just move things around as I want to. It really makes no difference as long as anything that's negative stays negative and anything that's positive stays positive. Those are the only requirements. So here I've grouped 2y minus 3y and 10 plus 27. Once I've done that, one last step, and that is to combine. Now I can combine 2y and negative 3y and 10 and 27. 2y minus 3y is negative 1y. Well, I don't write 1y. I write negative y. The 1 is understood. 10 plus 27 is 37. Since these two terms are not like terms, I can't combine them. The reason why they're not like terms is because terms are only considered like terms if the variables are exactly the same. Since negative y has y in it, and 37 doesn't have y in it, they're not the same variables, so they're not the same kind of term, and I can't combine them. Alright, I want you to give this problem a try. There's no distribution in it, so it should go fairly quickly. Take a moment, pause the video, simplify the expression. In just a moment, I'll put up the answer so you can check your work. As with the other problem, if you didn't quite get it, or if you get an answer that's different than my answer, feel free to make a note of it, and we'll talk about it in class or in tutorials. Alright, here we go. As you can see, I found some like terms. The p to the third are like terms. P squared is not the same because even though they're both p, they have different exponents, which makes them not like terms. I have 3p to the third minus p to the third plus 5p squared. I group them. And then I combine them, just like I did before. Alright, that's the end of this video, this section of videos. So, if you have any questions, feel free to ask me in class, and be prepared to do some work on this topic when we get to school.